a hard problem. I don't want to solve hard problems just yet. I think I'll give it like 10 days and then I'll start solving hard problems. So, uh, yeah, let's just search for some medium level problem. So I'll filter. I don't want it to be completed, so it's to do. And the difficulty is a medium level problem. And Python, just my favorite language. All right. So what do you have? Insertion sort list. Let's see what this thing is. So just to recap, insertion sort is like where you wait, how do you actually do insertion? What is insertion sort? I forgot. Okay. Oh, they have given it just like that because nobody actually uses order and square algorithms, but let's do it. So you're given the head of a single linked list, store the, they have an animation. Oh, that's bizarre. Okay, given the head of a single linked list, store the list using insertion sort and return the sorted list's head. So you have to, okay, start using insertion sort. So the steps are like this. Insertion sort iterates, consuming one element each repetition and growing a sorted output list. Okay, fine. So you initially start with nothing and then you just keep on, so you keep a sorted list and then you'll see an element, you'll figure out where is it supposed to go, and then you'll just insert it. So this is going to be this classic order n square algorithm because it's linked lists, so you can't, oh wait, so it's like, it's linked lists. Interesting. Oh, okay. Hmm. How much space am I allowed to use? Consumes one input element each repetition. Okay. I think I can make this n log n. Yeah. Yeah, I can. Right. I just have to do binary search and then insertion. Shouldn't be too hard. No, but I still have to move the arrays. Okay, that's problematic. Ah, yeah, you can't get the middle element, right? Yeah, you would have to have a binary search tree to have that sort of a structure. But then that's almost the same thing. Okay, that's just too problematic. Right. So it's n square in the end. The partially sorted list uh, contains only the first element, right? So you just do this arranging and then you return the thing. Fine. The number of nodes in the list are in the range 1 to 5,000. So 5,000 squared, that's order n square. That's going to be something like 25 times 10 power 6. Uh, I don't quite like that. Hmm. Yeah. Oh, okay. So the nodes are in a particular range. And these are not integers, right? Are they necessarily integers? No, not necessarily. So it could be floats as well. So in that case, you have to rely on the comparator. You just have to do it. There's no other way. So you just, yeah, insert. So you'll have to figure out where the thing is, which you can only do by iterating directly. Not nice. Uh, I mean, it's easy code to write, but it's not a nice complexity. But let's do it. Let's just do it. So a list node is of this type. You're given the head of the list. Right. Think about it. You can traverse the list like that. Yeah, so should you start with the Sential node? I guess so you could start with a null, right? Or a Sential node. Yeah, a Sential node is probably a better idea. So that the next thing is just that, right? Think about it. I mean, the first thing is just that. So, okay, so if head is none, just some edge cases, I'll just return none because then nothing's there. If head dot next is none, then I'll just return the head thing itself because once again nothing is there. Now, if, yeah, I mean, okay, this is just a, right, just the usual thing. Now, if head dot next is not none, it's something, in that case you can start the thing, right? So else, or you don't even need that else to start off it like that. So the sorted array I'll call as capital S, which is like sorted. So its head will be, yeah, this thing. So it will be like head, right? We don't want head dot, so head dot next I'll just set to something. So head dot next is basically what head is, right? And s dot next equal to none, right? So you've detached it and you put it there. Now we can start. So we have some value at least, right? Uh, so while s is, sorry, while head is not none, right? You'll just do head equal to head dot next. But so that's like ending the iteration. But before that, you have the head thing, and you want to use its value, right? So yeah, or you could just have the thing itself. So n equal to head, just putting it there. Head dot next is none. That's because I want to detach it. And okay, before doing that, I want head to be head dot next. This is pretty easy so far. Like, it's just linked lists, big deal. Okay, and then detach it, and now you have the node. Now you want to insert this, so you have s is there. um, yeah, so I want something which is like just smaller than that. Okay, so if it's going to be smaller than s, so if n dot value, so you want increasing, right? Yeah, so if n dot value is, I'm assuming that's okay, fine, it's less than s dot value, in that case you just do like n dot next is s dot, so it's just s, and s equal to n. Easy so far, right? Else, yeah, okay, and you can just continue, right? Okay, otherwise you have to start looking for it. So what you want is something which is just less than that, and yeah, so that the next thing should be bigger, right? So as long as the thing that you see is smaller, you will just keep putting it inside, right? So this will be like smaller is the head, no, not the head, s, right? Because we have affirmed that this is actually smaller. So while smaller is, so yeah, okay, while smaller dot next is not none, so in that case you can go forward, right? So it's not none, you'll do this thing. So it'll just be like smaller equal to smaller dot next. So just notice this, like order n square versus two whiles, right? Okay, now you also need a condition. So you check the s thing. Now you'll go update, and you'll see that is the new smaller value. So I'm assuming it's smaller, it may not be, right? Okay, before doing that actually, so if the next value is already like going to be bigger, then you found the thing. So if smaller dot next dot value, if this is bigger or equal, in fact, even if it's equal, it's the same, then n dot value, in that case you'll just want to put it in, right? So it's really like n dot next equal to smaller dot next, and smaller dot next equal to n. No problem so far, right? And you'll just break the loop. Okay, so that's if you found it. If you didn't find it, in that case, so this is while smaller dot next is not none, so this will end, and now smaller dot next is in fact none, right? Oh, also smaller is starting off at s, so it's guaranteed that it will have a, yeah, it's going to be there. Okay, and if that doesn't happen, if you don't break inside, then now you know that smaller dot next was going to reach none, right? So that's like this last element. In that case, smaller dot next is basically n. Yeah, and that's it. That's how you rearrange the thing. Okay, so that's the logic inside the while loop. and then you'll just return the head, or okay, you'll return s, right? So this seems okay. I think this is okay. So while head is not none, then you just rearrange the thing and then do the thing, you got a new node, etc. Right, so it might actually be none at some point. This is okay. Oh, but you're also dismantling the list, right? Oh, but it's okay. I mean, here as well, it's allowed to be dismantled. Okay, cool. Let's just run this thing. Oh, you also need some way to debug this. Hmm. How do you do that? So while head is not none, you'll keep on doing something. So uh, I also set debug equal to true. Okay, so just before doing everything, I'll be like if debug. In that case, I'll just print the thing, right? So I'll just print it. Uh, so while head is not none, or let's just say while some node, right? So t, let's call it t. So t is head, and while t is not none, what you'll do is just print the value. Let's also say L is this thing. So L dot append t dot value, and then t equal to t dot next. Just iterating and printing. That's all. And then, oh, by the way, you have to, right? I always do this thing somehow. And just print the thing. Or instead of appending, you can directly print because y is base, right? So print this. The end is nothing. Right. So this will just print the thing that we want. Yeah. Shouldn't be too hard. Okay, let's okay, you don't have to like this one. Once again, sorry, I've been doing JavaScript and TypeScript too much. Let's run this. Give me an error. Yeah, none type has no object. So this is okay, this thing head dot next equal to none. Okay, so you're saying, okay, if this is going to be none, then there might be a problem, right? So what you're suggesting is that, I see, the next thing is none. In that case, it's like the last element, right? So if head is not none, then you want to do this thing. So if head is not none, you do this thing. Great. Let's do it again. Give me something. A wrong answer, right answer, whatever. Time limit exceeded. Interesting. And I'm returning s. Yeah, true. Head equal to head dot next, s dot next equal to. So it uh, did it give me any output? It didn't give me any output. Okay, t equal to t dot next. Sure. So it must be this thing where it is stuck. So I'll just print something. So print debug, and then it should give me the thing, right? I hope so. It didn't give me anything. Hmm. that's not good. But I do have debug equal to true, so okay. Let's just see if this thing is actually working. So I'll just break normally. Right, wrong answer as expected. So it did 213, which is to be expected. Yeah. Okay, so now why is it going in the loop? So you have n equal to head equal to head dot next. Okay. That is to say n dot next, but you get the thing. Right? You just did unattached the thing. Wait a second, wait a second, wait a second. This is bad. Head dot next is none. Wait, but you just attached. Oh shit. I see. Ah, it should be n dot next. Yeah. Okay. So if n is not none, because if it is none, then that's a problem. Well, okay, we know it's not going to be none, right? Yeah. So just n dot next. You don't even need this thing. You know it's not going to be none because head is not none and n is head. So n dot next is none. It's just a normal thing to set, right? Okay. Let's try it again. I don't think it's going to change. It's still going to be the time limit exceeded, but still. Okay, I don't know what happened and why it was doing that, but it seems to work. Okay, these two worked. Let's try removing this debug stuff and just now let's just submit this, I guess, and run and submit. Okay, cool. I don't really care what time complexity I have. Yeah. I mean, it's just wait. So some of these people have done it like really, really fast. I wonder how they are doing that. But yeah, for now, let's not think too much about it. It's just a order n square problem, not complicated. Let's go to something else. This is also a medium level problem. We'll just go with that. Okay. So given the head of once again linked lists. Why linked lists? I don't know. So you want to return the list after sorting it ascending order. That's all. That's given. Number of nodes in the list is in the range 0 to something. Can you sort the linked list in order n log n time and order one memory I constant? That's basically like, oh yeah, that's heap sort. Basically heap sort. Yeah. But this is a linked list. Think about it. For a heap sort, you would have to put it in a heap. Yes. Space complexity is order 1. That's what you're saying. That's going to be problematic. What about merge sort? Yeah, a merge sort is a simple way to do it, right? Because let's say you want to merge two linked lists which are sorted. That's pretty easy. You just want to, yeah, right. So how will this go? It's going to go recursively, obviously. So you'll be like split the thing into two and two and two and two, so on. And then you'll just keep on merging. Sure. But that's not technically order one space. That's more like order log n space because you have to have stack frames. So it's still not order one. Constant space. Is there a better way? Constant space. You still have to have the recursion stack, right? Yeah. So that's not constant space. Come on, think about it. Ah, You don't want to do something like insertion sort or anything like that. Okay, so merge sort and heap sort are the only two real ones which you can use. Other than that, I don't know any order n log n algorithm. I don't, yeah, I really just don't know any other order n log n algorithm. Interesting. So heap sort is out of the question because it requires indices, right? It requires you to know what your child element is. So you can't do that. So the only thing left is merging, but that's log n space. So how would you do it? Maybe having the stack for like DFS. Sure, but even the stack itself will grow. There's no way to think about it. Come on, don't give up like that. Think. Just, hmm. Wait a second. Wait a second. Yeah, you know that that's going to be. Oh, interesting. Oh, okay. There is a way. There is a way. I think so. So all you have to do is remember. Yeah, okay. I think I'm getting it. I'm getting close to the thing. So assume that you did actually segment this, right? And you have some sort of a coloring scheme, right? So the end nodes, the nodes, or maybe let's say the start nodes, right? The nodes where your segments start, they're colored red randomly. You could just change the value somehow to make that happen, but let's assume that that's happening. Then you would be able to identify where the thing is like next, right? So now you know how to pick two of these. Is it going correct? Yeah, two segments. And so once you merge that, what you'll do is like you'll end up getting another segment because you are going to go at the right. Well, okay, that just merges normally. Huh, that's not good. That's once again that just becomes n squared. It's problematic. Ah, you have to do recursion. There's no other way. You can't do this in order one. That's the thing. Okay, let's just for now let's just try doing the most sane approach. That is, we'll do normal merge sort, right? Okay. So I don't like this class-based approach. I'll just be like, so first you just want to merge two linked lists. So it'll be like L1, L2, and then you want to do this without creating new nodes, right? Yeah. Uh, so it'll just be like L3 equal to none or whatever. Or you will just start with whichever one is the so edge cases first. So if L1 is none, just return L2 because, yeah. If L2 is none, return L1. And otherwise, both of them are not none. So one of them must be smaller, right? Yeah. So if L1 dot value is less than L2 dot value, so it's just we need to have a head element, that's all, right? So it's like L3. Then L3 equal to L1, else L3 equal to L2, right? Obviously, you also have to detach the thing. So now L, yeah, L3 is L1. So L1 is just L3 dot next or L1 dot next or whatever. Oh, yeah, right. And then L3 dot next equal to none. Yeah. So all of this is just so that you can have the head thing. So L2 equal to L2 dot next, and L3 dot next equal to none. Okay, now since you have a head, we can start. Okay, so while L1 is not none and L2 is not none. I think I've seen this somewhere, I don't know, merging, whatever. So if, once again, the same logic that if L1 is, so you just figure out which of them is the smaller one. So by the way, these are already sorted, that's one thing. So you have the pointer and then, yeah. Oh, you also have to have the tail, right? So tail equal to L3 for now. So if L1 dot value is smaller, let's say, in that case you would want that to go first. So you'll do exactly the same thing. You'll detach and you add this thing. So it's just tail dot next equal to L1, right? L1 equal to L1 dot next, and you want to disconnect the thing. So tail dot next, because tail dot next is the L1 node. So that's going to be equal to none, right? That detaches the thing. Sure. Similarly, if this doesn't happen, then do the other thing. So it'll just be like tail dot next equal to L2, L2 equal to L2 dot next, and L2, so tail dot next equal to none. Once again the same, right? Now you can do, you cannot do comparisons anymore because one of them is none, right? So if L1 is none, then that means that whatever is in the L2 thing, you just attach it without caring. So all you have to do is just tail dot L2, sorry, tail dot next equal to L2, right? uh, and similarly, if L2 is none, in that case just attach L1, not really thinking too much, and then you just return the thing, you return the head, so just return L3, right? That's merging. uh, yeah. Okay, now you want to think about merge sort. So you are given a list, which let's say call it L, it's a linked list. Yeah, okay, sure. You want to traverse with half of the thing and then do it, right? uh, wait, so traversing to the half of it, that is, it's still order n, it's not too problematic, so you need to get the length somehow, right? Or you could just add all of these inside. Hmm. Yeah, right, you just have to get the length somehow. So we'll just say length is 0 initially. Okay, first just have the base cases. So if the list is none, then you just return that. Return. If L dot next is none, that is it's a singleton, and just return L. Now that's out of the window. You just have length equal to 0. Now while just call it L, call it N for now. So, and you just need to have a node. You already used N, so L. So N equal to the head. So while N is not none, what you'll do is just N equal to N dot next. You'll increment L. The usual. Right? Counted one, counted one, counted one, and then eventually it'll be none. So if it's like, yeah, it works. That's your length. So now you just want L equal to L divided by 2. And now while, yeah, once again, this is kind of stupid, but we'll have to do this thing. So this is basically telling you, uh, like, let's say you have a a list of 3 elements, right? So then 3 divided by 2, that's going to be 1. So you want to make one jump, right, from the base address, I guess. Yeah, because then it's like 0, 1, 2, so you end up at 1, so you split it in half correctly, right? That's where the new portion would be. So just before that, you have to cut it somehow, right? Or you could cut it after that as well. So let's say if it was like 4, then you have to make two jumps. So at 0, you'll be like 1 and 2. So you have to cut it just before the thing, right? You don't have a previous pointer. So you have to decrement it by 1, I'm assuming. Yeah. Right, so make that -1 jumps, right? So while L is positive, right? Just have to make jumps. So n equal to n dot next, that's a jump, and decrement it, number of jumps to make, right? And that will reach the thing. So now you'll be like, n dot next is the other thing. So let's call it L dash is n dot next. So far so good. So okay, does this work for 2? I assume it does because it's just 1, so 0 jumps. And then the next one, so it's already there, fine. And all you have to do is just n dot next is none. Now you have broken it, so now it's L and LD, and now you can just do merge sort. So okay, on each of them separately. So you will like L equal to merge sort L, and LD equal to merge sort LD, right? And then you'll just merge this. So LDD equal to merge L and LD. Yeah, because now these are like sorted. And then you just return the thing. So return LTD. Fine. Yeah, I mean it takes care of the cases, right? And that's how you do merge sort. So this will just be like return merge sort. Or you could say head is this thing. It will just be like L equal to merge sort the head, and then it just return thing. So return L. I want to print this basically somehow. Yeah. So we'll just say debug equal to true. So now, yeah, if debug just a second. So that just prints the thing. Sure. Similarly over here as well, I want to debug this or not. It doesn't really matter. Just knowing what we're trying to merge is probably enough. Yeah. So like split it, and or you could just say before print. So before and after, right? Yeah. Right. Okay, so this should be doable. So right now, like debug is true, so it's gonna print the thing. Uh, let's run it on a test case as expected. Merger sort. Okay, great. Where did I do that? Horrendous crime. Okay. Yeah, that's going to happen. Like, there's more stuff that's going to happen, by the way. As expected, wrong, because initially it's always wrong. Then I find a way. So before it was, oh, Why is the formatting so broken? Okay. Yeah, this is not going good. I'll just print the space. Right, and then I'll just print this thing. Like print nothing, basically. I should fix the formatting. Okay, let's see what's happening. Before it was 4213 as expected. Then it became 42. So it's the first two, right? Then you're trying to do 4. And you're also trying to do 2. Okay. And after it's 2 4. Wait, oh, so if it's a singleton, you just return it. So it's okay. And then that became 2 4 as expected. Completely fine. And before it was 1 3. After it was still 1 3. Okay, but then after it wasn't 1 3 anymore, it just became 1 4, which is bizarre. That shouldn't have happened. So you have like two of these, and so it's hard for it to merge. So 4 2 and 1 3 it couldn't merge. Why? Let's see. Yeah, because I'm pretty sure it's this thing which it's talking about. Why is it 1 4 directly? It's as if. Oh, okay. Interesting. Let's see what merging is doing. So if any of this is none, just return the thing as expected. If L1 dot value is less than L2 dot value, then L3 is L. Okay, so in any case, L3 is going to be there. So whichever this is the smaller one, right? And L1 dot next is what L1 bit. So you are reseeding it. Yeah. And L3 dot next, which is just the thing that was assigned. That's none, which is expected. That's completely fine actually. And so now tail is L3. Okay. Cool. There's the off chance that there's something weird with the Boolean logic, but I don't think it's going to be. Still, just for surety. So till both of them are not none, what you'll do is if the first thing happens, that is L1 dot value is less than L2 dot value, right? So both are not none. In that case, tail dot next. So you're choosing which to append. It's going to be L1 because it's smaller. And you also want it to be going forward, right? And yeah, so tail dot next equal to none. That's to be expected. That's completely fine. Okay. Yeah, this isn't a problem. Whichever one is the smaller one, which is what we do. Let's do it with a dry run. Let's say you have 1 3 and 2 4, right? So what's going to happen? So L1 is 2 4 and L3 is 1 3. So L2 is 1 3, right? So first it goes to the else thing because 1 is smaller. So now it's like L3 equal to L2. So it's the one thing. L2 is L2 dot next. So it's the 3 thing. And L3 dot next equal to none. So the 1 dot next thing is none. It's broken off, which is fine. What's happening? So then you have like tail equal to L3. Cool. This is also the head. Let's try to print this thing to see what's happening. So I'll be like print merged, merging, or just merge. Yeah. And the end should be this thing. Right. So print tail dot value. Okay. Yeah, this should be okay. Let's just think about it though. The L1 and L2. The tail is still there. Yeah. And returning L3 as expected. Shouldn't be a big problem, right? Like one of them is none, so you just choose the other one, regardless of whether it's none or not. Yeah. What happens if both are none? Well, then it's just none, none. It's not a problem. What if L2 is not none? And then this doesn't trigger. That's all. Okay, let's try to run this. Once again, it's doing some weird stuff after merge 2. Merge to 2. Okay. Okay, what the? Merge to 1, 1, 1. The tail is not proceeding, that's the problem, right? Yeah. Oh, okay, okay. I see what went wrong. So it should be like tail equal to tail dot next, because yeah, okay. I'm stupid. That's all. Anyway, now this should work. Okay, cool. As expected. Uh, so I don't want these print statements. Cool. And in the merge sort as well. So if debug, so it'll just be like debug equal to false. So then this doesn't ever trigger. Cool. Yeah, no output. That's yeah, okay. It's okay. Cool. Move on. It's nice. The sort, the filtering is actually staying. Okay. So evaluate reverse Polish notation. We're given an array of strings that represent arithmetic expressions in reverse Polish notation. What is that? I don't know. Valid operators are okay. So it's like okay, fine. It's like a stack virtual machine. So let's say you have 2, 1 plus 3 and multiplication. So what that means is like 2 plus 1. So whenever you see an operand, you just do something. Sorry, operator, you just do something. And yeah, okay, this is usual. This is like a stack virtual machine. So what are the rules? Valid operators are plus, minus, multiplication, and division. Each operand may be an integer or another expression. Another expression. What does that mean? Oh, are there parentheses? Nope, no parentheses. The division between two integers always truncates towards 0. Okay. There will be, uh, so it's either integers and then it's like float division. So, sorry, a proper division to integers, right? Won't be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. Okay. The answer and all the intermediate calculations can be represented as 32-bit integers. This doesn't look problematic. Yeah, okay. Evaluate the thing. So, so given a bunch of tokens, what do? You just do a stack, right? So just do appends and pops, that's all. So I'll be like stack equal to nothing in there. So for token in S, uh, so you just have a bunch of things. If token equal to, you could have a plus, right? In that case, all you have to do is take out the operands. So operand 1 or operand 2 is more like it, equal to stack dot pop. Operand 1 equal to stack dot. This is just this is just stupid. And I just say s dot append operator 1 plus operator 2. So operand 1 plus operand 2. No big deal. I'll just copy paste this thing for a bunch of things. So and it should be like else if over there. Yeah. So it's minus, then it's just minus. If it's, so it's plus, minus, multiplication, then it's just multiplication. So these are going to be integers, by the way. Yeah. uh, Else if it's division, then you just do division. This is so boring, like this was not even 2 minutes, right? Else we know for sure it's going to be an integer because of the things that they have told us, that the input represents a valid arithmetic expression. Oh, can it be negative? Even if it's negative, the integer thing does the thing. So it's just uh, I don't know, will be like s dot append whatever the token thing is, so just convert it to an integer token, and it's base 10 as expected. So this is all like in 32, nothing complicated, no overflows, whatever. uh, and then you just return the, yeah, this should not to be just one, but okay, by the way, this is not small s, this should be capital S over there. And then you'll just return the thing, right? Yeah, you just return s0. I'm doing it blindly without even validating whether or not it's correct, because they have told us that it's going to be correct, so it's fine. So constraints are tokenized either an operator, okay, or an integer in this range. Negative is fine because the integer thing takes care of it. Yeah, this is okay. Yeah, it's just 10 power 4. Cool. So I'll just run this. This is like what, order n? Ah, shit, sorry. For token in tokens. Yeah. Huh. Wrong answer. Oh, it's s minus 1. I mean, okay, but it shouldn't matter, right? Okay, let's see what's happening. So you have 10, 6, 9, 3, something plus. So 9 plus 3, that should be like 12, minus 11, multiplication, division. Okay, this is kind of a lot. uh, let's see what happens to the operator. So for plus, this consumes these two, so now you have 3, 4, and so that takes away 2 and puts 1, so that's one, minus 1, right? So now it's just 3, right? So first it was like 4, 4 became 3, then became 4, then became 3, then became 2, then became 1, then became 2, 1, 2, and 1. So this should be a single thing. So why wasn't it there? Hmm. What could have happened? Yeah, all my operators are correct. So return O1 minus O2. Okay, it could be that. Yeah, let's try something where there's some minus somewhere. Okay, let's see what this thing is doing. So it's 4, 3, 5, and then okay, so 13 and 5. The auto thing is there. It's exactly this thing actually. So this should be 22, but what's going on? So first you just do a plus, right? Wait, what? Okay, 9 plus 3, whatever the result is, that times negative 11 as expected, then 6 divided by that, because okay, it's O1 and O2. Sure, that's how it should be. So what's the problem? And I've done the same thing. There's no other way. I'll have to debug this thing now. Yeah. Okay. So I'll be like print s. So this is for this thing in token, right? Yeah. So print. Okay. Instead of doing that, I'll just be like just before the whole thing happens. So for token and tokens, I'll just print the token and then the s thing, right? So that will give me a good record of what's happening. Uh, and then I'll just before returning, I'll be like print s. That will give me a good idea. This should really not happen though. Okay, 10 and just got inserted. 6 got inserted. 9 got inserted. Sure. 3. Okay, so you're going to do plus for 9 and 3, which gives us 12. Fine. Then you got minus 11 got inserted, and then there's a multiplication, so minus 132. That's okay. So far, it's not problematic. I think that's also exactly what they are doing. 9 plus 3 times minus 11. Right. Which is just 12 times negative 132. Fine. Then they're doing division. So it should be 6 divided by negative 132, which should give 0 apparently. Let's see what they gave us negative 1. I see. Okay, why did that happen? What does division by negative 132? Okay, this is some flaw in Python, right? That this division shouldn't give us this, but it gave somehow. Okay, we'll just do it like this. We don't have the sine function, do we? Huh. And we can get it from math. Or whatever. I'll just be like, if the other one is negative, then do the transversal thing, right? Yeah. So if like O2 is, so this is all because O2 was there, right? Yeah. So if O2 is, or we just do the normal thing, right? I'll be like negative, will assume it's false. Or, okay, negative is just, uh, if like o1 less than 0, XOR, right? So XOR is not there. I can use this thing. Right. Or you could just do it like this. If o1 is less than 0, or you could just do it like neg1 then neg2. So neg1 is o1 less than 0 and neg2 is that. Just a second. Right. So if neg1, you just do like b equal to negative y. If neg2, and you just append b. Yeah. And then this should happen. Cool, let's just try doing this now. As expected. So I'll have to remove all these print statements. Where am I printing stuff? Yeah, this is one print, and this is another print, and I'll just submit. I think it's okay. Cool, move on. This was just too basic. Like, this is stacked virtual machines are, I mean, like the most basic thing that one could ever do. It's a reverse word string. Given an input string, reverse the order of the words. Okay. A word is defined as a sequence of non-space characters. Non-space characters. A word in S will be separated by at least one space. Return a string of the words in the reverse order concatenated by a single space. Reverse order concatenated by a single space. Okay, so the sky is blue is now like blue is sky. So just reversed it. That's all. So it could contain leading or trailing spaces, multiple spaces between two words. So this is all, I don't know why this is all compiler stuff. Like this is classic compiler shit. I mean, yeah, this is exactly what I was doing. But this is not really a problem. The returns string should only have single space containing words, not include any extra spaces, etc. etc. Right. So how do you do this thing? You just have a current, which is initially nothing. So for character in string, you are like, if it's, yeah, so if it's a space, so if c is equal to a space, or okay, you could also have this thing, or c equal to some tab thing, right? And what you want to do is just check if current is the space thing. So if current equal to space, it will do nothing. So if current is not equal to the space, if it's more than that, if it's like some other thing, then you'll just want to append this. So words, I'll just be like words dot append the current thing. Otherwise do nothing, just keep on moving since it's just spaces, right? Spaces do not affect anything basically. All right, else, so if it's not a space, in that case it'll be like current plus equal to whatever this thing is, this character, and there you go. That's how you do it. You know, yeah, I mean, let's not use this, let's actually use this list, right? So now this should be, So if current, otherwise it's just empty, right? The usual, just add the character, etc., etc. The words get this stuff, and yeah, and this just return the reverse of the words. So words, this should be the thing. Let's just run this. I don't know. Okay, interesting. So it was the sky is blue. The expected is blue is the sky. Blue sky. The I had this. Okay, I get it. Right. So the hacky way of doing this is like basically adding extra space, which is what I'm going to do because I like to be hacky. Yeah. Basically, it will force it to put the thing inside. Yeah. You shouldn't really be doing this, but like doesn't matter now. Like it's still something is weird. So now it's blue is sky the. Wait, what is my output? Oh, okay. So you don't want this. You actually want space separated. Joining of this thing. Fine. Cool. Yeah, that was easy. Yeah. Very standard compiler stuff. I don't know why it's giving me compiler related things. So this is done, right? Reverse words in a string. So now I'm going to go to this, I guess. Maximum product. So is the reverse word? It's still there somehow. But like I've submitted it, so it's done. I don't know. There's some weird stuff. Anyway, given an integer array, find a sub-array that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. So you just want a sub-array that has the largest product. And then, so it's as if like, if you just had a log of that, you would have that thing. But okay, you also have to deal with negatives, that's the problem. Some of these are also going to be negatives. Thought so. Yeah. So you could have the largest as well as the lowest products, and then it would all make sense, right? So just consider like the first element. If this is going to be involved in the product, what you would want? You would want that all the other elements, what is the largest product that you have? And you also want what is the smallest product that you have, right? So if you have that, then depending on whether this is like positive or negative, you can do the thing, right? If this is positive, then you know that the largest product, well, obviously largest product is also positive by definition, otherwise it's just 1, right? That's like identity. Oh, it can also be 0. Fine. The largest product is non-negative. Okay, what if there's only a single negative number? Then you may not have it. So the numbers can be like that. Okay, that's some other thing which I'm not understanding. So the test cases are generated so that the answer will fit in a 32-bit integer. Sure. So the main question is what happens if you're given an empty array, right? Okay, you won't actually be given. So what happens if you're given an array with one negative integer? Then that's a problem, right? Oh, also a sub array is apparently a contiguous array. I didn't know that. I thought it's just like any array. Then it would just be like DP. But you want a sub array, right? This sounds awfully familiar to something. Products, summaries. Interesting. Yeah, this is dynamic programming, I'm assuming. Something like that. First, you gotta figure out the negative stuff somehow. So, like, yeah, for every one negative that you will choose, you have to choose another negative, right? Why do you feel this can be just done with sorting and stuff? Right. So let's say you sorted this thing, sorted the list. What happens? You just have a bunch of negative numbers at the start, then you may or may not have zero, and then you have a positive numbers, right? Okay. Now, oh, but you can't do that. You can't rearrange the thing. Ah, problematic. So, okay, then the sum is like just division, isn't it? Yeah, we could store the product and then divide by the right. So let P sub I be the product of all the elements till AI, right? Then Pi by Pj, that's going to be the product of all the elements from j plus 1 till I. Sure. And then what? You just want like the order n square iteration stuff, and from that the thing. Okay, that is probably the way to go. Let's just see what the constraints are. So it's 2 times 10 power 4. So this looks doable, order n square, right? Yeah. Yeah, order n square, sure. So you will be checking order n square in any case. But okay, the space complexities. Ah, do we have to check order n square? That's the question. Well, it fluctuates every single time. So you might just have to. Let's assume it was like sums and something like that. So if it was a sum, you would do the same thing, right? Because it's just like you convert it to log and then it becomes a sum. But you know, in that case, what would you do? It may increase or decrease, right? Largest increasing subsequence. Okay, that's a different question altogether. That's not the thing. Largest contiguous subarray with it's like biggest sum. I don't want to. Why is it doing that? Anyway, think about it. You have to do order n square, right? There's no other way, and it seems like it's meant to be order n square because it's like 10 power 8. Problematic. 10 power 8 is a bit too much. You can't use db, right? You use it to populate stuff, but that's about it. You don't want an order n square thing. You want something like order n. How would you do order n with this? Can't you sort? Okay, so we'll have to go to some proof-based stuff. There's no other way. Okay, think about it. Suppose you have somehow figured out the perfect thing, the largest product, right? What are the properties it will have? First, it has to be positive. If it's not positive, then you just might as well not have anything, and then that's one. So that's still a bigger product. So the product is positive for sure. In which case, that means that to the left and to the right, you cannot have positive integers, right? So if it's 1 or 2 or whatever, and that's a messed up thing. So this is integer array. You don't have floats. That's a good thing. That means you can grow to the left and right. That's a problem. So the only time that you would have an array like that, right, is if you cannot grow. That is if you have a negative on the left and a negative or a 0, a negative or a 0 on the left and a negative or a 0 to the right. Yes, it's between that you would have your array. Okay, cool. Interesting. So now I'm thinking that Yeah, okay, this is starting to make sense. So every time you have one negative, you also want another negative, right? Mm-hmm. Unless there's a zero, because if there's a zero, that's not one. So wherever there's a zero, that just breaks it, because you cannot include that at any cost. So break with zeros, and then for the individual ones, figure out the product. Yeah, it seems like a strategy. What if it's one? I mean, like, that's the problem. If there's a zero, then zero is a bare minimum. Otherwise, if it doesn't have it, then over here, why is the output zero and not one? So you cannot have the empty subarray. Should have at least one of these. So if it's like a just one negative number, in that case, I'm just going to assume it's just that. Okay. So break it at zeros. You know that zero is a possibility. You also know that now that you have broken, yeah, those are the ones which should be there, right? You cannot have negative one. So just teacher. So now you know that the subarrays that we have broken into all only have non-zero numbers. So the absolute will always be growing. The more you include, at least it won't go down. So that it's like, okay, on negatives you are going to think of them as checkpoints. So you just convert that product like that. Yeah, right. So if you're going to include this, you also need to include the other one. Yeah, right. Come on, think about it. Even number. Even number. What does that mean? You either leave one negative or you don't leave any negatives. Only two scenarios. It's impossible for you to be leaving two negatives, right? Because either you are already positive and you include both of them, or you are negative then you include one of them. It's not possible for you to be leaving, right? So there's only two, okay, three distinct possibilities that you can have. You can have the whole thing, the whole array, subarray, sorry, or you could have one leaving the negative side from the left, or one leaving the negative number from the right. Those are the only possibilities, right? So the whole thing is not to be, yeah, this makes perfect sense, right? So okay, we'll just make a, okay, so once you have broken it down, and that works in order n, right? So you can just keep on accumulating these guys. Yes. Okay, I think we can do this then. So first we just need to process it for things which do not have zero, right? So it's like non-zero biggest product. So non-zero big prod. Bad name, but that's just how it is. And so I'm going to give it what? An array starting index and an ending index, right? So it'll be like product equal to 1. I also want to know how many negatives there are, right? Okay. So actually they can calculate all three numbers, right? Yeah. And first I'll just calculate the biggest one. So also like negatives. I mean, okay, it's going to be negative then. That's like odd negatives, otherwise even negatives. So it's completely fine. Yeah. Okay. So let's say capital I is the thing, or we just have start and end. So for I in range, start to end, I'm like a sub I is what I'm at, multiplied by this thing, so p times of, right? There you go, that's the product. So if If p is like positive, then it's return the thing itself. Return p. Okay. Otherwise, if it's negative, you have two optionalities, right? So first I'll be like, so I'll wait till it reaches negative, the first negative, right? Yeah. So I'll say like found equal to false. Okay, for I in range. Okay, I'll do the p tutorial after that. So now we know that the first negative is there. So now I'm like, for j in range, right? That's the thing. And then I'll just like break it after this is done. So that's skipping the first one, right? And now I'll do the same thing but in reverse order. So now I just want p2 equal to 1. Found is false initially, right? So now for I range, so we'll start off at e minus 1 and the way till s minus 1, and then it'll like decrementing. Sure. So the moment you find the first one, yeah, right, found is true. Wait, did you even need the, no, but you like broke off in any case, right? Yeah, so you don't actually need this thing. You know this is going to happen at some point because there's a negative. You just break anyway, right? So yeah. So now for j in range, so you'll start off at I, right? So you know, okay, it's I minus 1 because this one is negative. All the way till start minus 1. Now it's p2. And then you break it, right? When all of this is done. So these are your possibilities. And I'll just return whichever is the biggest. So return max of p1, p2, right? Because p is negative. So one of these has to, so these are going to be like positive, right? Yeah. So there you go. That gives you the maximum product for, because it's all integers in the end. Okay. So now I'll just make a stack, and also the biggest. So biggest is not 0 initially. I'll just say it's none. Okay, cool. Let me just directly check 0, right? So if 0 is, okay, so if 0 is not in there, so 0 not in nums, then we'll just return this thing, right? So return uh, this guy. Oh, also, so what happens if there's only a single thing? So if start is equal to the end, okay, is equal to n plus n minus 1, right? If it just so happens that, yeah, there's only a single element, in that case you just have to return the thing, right? Yeah, so just return the element. So return a sub start, whatever that thing is. Now I'm just assuming what I'm doing is correct. Okay, seems correct enough. Okay, cool. So if 0 is not in nums, then we just like return. Oh, you also need the n thing, right? Yeah. So I just require the array, which is nums. We require the start and the end. Yeah. Otherwise, if 0 is there, in that case, you'll just keep splitting it and then do the thing, right? Okay, so it'll just be like s equal to this. Or we just say ing, right? Because you don't even have to do this thing. So it'll just be like start equal to 0. Okay. And then end is wherever you have a negative. So for in range n, if what happens if the start is itself is negative? Yeah, that's a problem. That's a good question, actually. Yeah, whatever. Just do the thing. So if a sub e is equal to 0, right? That means that's a breakpoint, right? So if start is equal to the end itself, then that's a problem. Then that means there's nothing over there, so just continue. You haven't found anything, right? Otherwise, you have found anything because like e is bigger than s. Yeah. Okay. Else, you want your start thing to be e plus 1 because you know that e has 0, so the one next to this. Before that, you have to check the thing. So that I'll be like, okay, biggest is 0 initially. So now I'll be like biggest. With this messed up stuff. So none of this contained 0, that's why it's there. Yeah. Yeah, this is okay. Nums and this thing. So max of this with itself, and this should do it. And I'll just return biggest. So this number, yeah, it's okay. I don't know if this is going to work or not. I have zero hope. Okay. Regex. Okay, this is it's not subscription. Okay, what is A? A is the problem, right? Yeah. There should be nums. Let's try again. Yeah, so if 0 is in there, in that case, the biggest is 0, right? Oh, but it's a 1 as well. Yeah. That is if this is an empty array, that which, yeah, right. That's a problem. So when could it give 1? When you don't have anything over there. The singleton is just that. If it's not a singleton, then it cannot give something like that. Start and end being the same thing is problematic. We already did that. We just continue over there. Why would it give 1 though? Okay, just gonna print the thing. So I'll be like possibility is this, and I'll just print the thing. So print nums from start to end, and then the possibility. And I'll just reuse this and the possibility, right? Just to see what's happening. Yeah, so it's somehow getting an empty array, but why? So first time it does it, it's so you have start equal to 0, okay, then you reach 0, so now you're like nums, and how could it be the same? Equal to e plus 1. Oh, oh shit, so stupid. Ah, I hate this. Should be like this. Just a second, what's happening? How much do I have? 29%. That's quite enough. I just feel so bad, like right now. It should have been like this. And if nums equal to 0, then you do this stuff. Like the else is I hate this. Yeah, as expected. Right. I don't need to print this. I know image saver is on. Okay, so I'm gonna submit this now because yeah, I guess it's fine. Sure. Okay, great. What happened? So if 0 is there, oh, okay, cool. Oh, you're just returning. That's the problem, right? You don't just return. Wait, no, 0 not enough. That's fine. Now you just have biggest is 0. Okay. Wait, but this should have given us the correct thing, right? 2 is a possibility. So why did it not think of it like that? So initially it starts off at 0, then you're like, okay, this is 0, so start over there, and now you have start and end as the same thing, so it just continues, right? And then it goes to the, yeah, that's all it is. Oh, okay, it should be range n plus 1. So that is to say it can also reach n. Yeah. Ah, I see. So you cannot reach it directly, right? So at some point it will just not go forward. There is a hacky way to solve this. The question is, do I want to do that? I guess I can probably. So I'll just be like noms dot append. Yeah, I know this is bad, but that works. And now I can go till n plus 1. So now it's like the last one is guaranteed to be 0. So we'll just do that thing directly. Okay, now this is problematic because what if it's a negative? Then that's not good. Okay, so now what's the condition after all of this, right? The condition is that start is somewhere and then end is somewhere. And we know that the start thing does not actually land on a 0. Yeah, right. So that's like you don't just continue, you have to increment the start thing, right? Start equal to end plus 1. The problem is that it's still 0, so you don't want it, right? Yeah. So when it does the last one, it's going to be that. So that is not a possibility. In that case, you just want that, right? So now start is something which does not have a 0 over there, right? So now it's like if start, so if end is, okay, the end is should be n, right? So if start is equal to n, in that case that doesn't make any sense, so I'm just going to not do it. But if it's less than n, you can do this thing. You can do like biggest, yeah, it's fine because last 0 wherever it was stated, it completely does that. I think it's okay. Let's try it out. Yeah, it is. Cool. Hey, nice. This is a nice thing. It beats 98.57%. Maybe because I relied on math and not just some technique which they use in DSA or whatever. But this is pretty obvious, like what's happening. So yeah. Okay, cool. I guess I should stop because battery low. So I'll see you guys next video. Bye.